Right, hello there. So we're going to have a look today is one of the ALT3s. There's lots of different ones, and I've already shown you the most basic one, which is I like to call it the calculator kind of model simulation. Um, it can be done very well, the calculator model simulation one. This one's a bit more sophisticated. Um, so I like to call this kind of, it's more like where you're getting into the visual simulation style. There's lots of of ways you can actually implement this. The one I'm going to do is a classical growth simulation model, but this can be applied financial, biological, ecological, you name it, you can apply this one. You can extend it to loads of different variations. But the key bit of this model simulation actually it gives you a visual. And I think for a lot of the students, this is what you need to be able to show some visual simulation based on your modeling. Okay, so listen, we'll get into it. It's not actually too hard, would you believe? I've seen harder ones, but let's start with the basics. We need to get a couple of inputs. So we're going to look at a growth algorithm. Some of you might have done this in either geography or in maths, but we'll have a look at it anyway. So we need a population, right? And obviously population will always go in as an integer value. Can't go in as anything else. So that'll bring in the current population. Okay. We need a start point in terms of years, because obviously it's going to give it a projection, hopefully. And it's the same thing again, so I'm just going to copy this line and just change what the head. So let's just copy this line. I don't know why it's doing that. Control Z. I think I know what's wrong. Control C. Control V. And what is the current year? We've got the year, we've got the current population. And let's see what we're going to need all the current things basically. Current birth, current birth rate, and again, these are all going to be per thousand. So, for every 1,000 people, the birth rate is going to be whatever. Again, if you're doing geography or you're doing honours maths, you'll know what to put in here. For anyone, you would have all done junior cert maths, and you'd all have done junior cert maths, financial maths, and you'd all have done junior cert maths, financial maths, compound interest. And basically, this is all compound interest. Remember, in compound interest, you start with a certain amount, you've got an interest rate which adds on to that amount, and then you've got a number of years. And this is basically what we're doing here, except with growth of people. So the birth rate would be the interest rate that's adding on new people every year. And obviously, not only do people get added on every year, people die every year. We need the death rate. And obviously, just to go into kind of the logic of it, if the birth rate is greater than the death rate, the population should increase. And if not, population will decrease. In a lot of first world countries, the birth rate is greater than the death rate. Sorry, the birth rate is less than the death rate, so the populations of those countries are decreasing over time. The most popular example there would be Japan, Russia, where there are more people dying than there are being born. And again, you can go into all the kind of the background about why that might happen. And there's another then, and again, this is very topical, current migration rate. So again, in certain countries, while you might have less people being born and more people dying, if you have a lot of people emigrating to your country or migrating to your country, it'll actually compensate for the fewer people being born. So you see a lot of first world countries are relaxing their migration policies in order to get new blood basically into the country. But of course, that comes with certain issues. And then there are certain countries who, even though they know, I bring up Japan again, Japan has a very strict, virtually non existent migration policy. And virtually nobody is allowed to migrate and live permanently in Japan. And even though they know this is population suicide by not introducing, they've gone down this route for their own cultural reasons. But anyway, so one thing I might do here is I might change these to floats, because usually they're not as whole number. Because we're dealing with averages when you're talking about the birth rate, the death rate, the migration rate. You can sometimes have it like there's 4.5 babies born per 1,000 women. That type of thing. So I'll make them floats just to allow you to put stuff in there. So once we have that done, then let's try and think. That's what it is at the moment. Okay, let's see what it might be projected. Because it's not going to stay the same. A good kind of population statistician be able to, figure out over time. For example, the death rate per 1,000, it might actually go down if the health system improves in the country, or people start living longer. The birth rate might decrease more as people become fatter and less fertile and weird things like that. And the migration could change because countries might tighten up or country might loosen up over time. So you need to be able to adjust into the future those possibilities. And all we're going to do is put the same numbers in again. As the current. You see, it's an awful lot of very simple inputs here. Again, these will go in as float, so I'll change that. Change that. Change that. Put in future, projected. Projected birth rate. And projected death rate. And I'll put in here projected migration rate. Right, so we've got all these inputs coming in, so we need some type of formulaic system. Okay, so let's say you want to model it over X number of years. Okay. You need to have a certain amount of years. So 1,000 years into the future, a million years into the future, that type of thing. So now we're going to have to create a couple of lists I'm figuring. Okay, we need to you need a list so that when we run our calculations for this year and then next year and then the year after and the year after, each time we get a new population based on our formula, we're going to have to append that into a list, because we're going to need those numbers in a list if we want to visualize this in some type of graph, because that'll form one of your axes. Okay, and then obviously a corresponding year incrementing by 1. So for let's say for 2023, sorry, 2024. So if I want to, I'll get a population for 2024 and I'll have the year 2024. So that'll be in two different lists, and then I can obviously, each indexed in each list will marry up with the element in those lists. So I'd be able to visualize this X and Y axis, just like you would in doing any kind of statistical graph in junior and even cert maths. So population list and the year list. We make these empty, obviously. There's no point in the population list. I might come back and do something with them in a minute. We'll get them in there so I don't forget them. So let's get this graph going. Okay. So let me have a look here. Let's think. I'm trying to remember back to my junior cert or my leaving cert biology when we were doing growth of bacteria. So we're going to need some type of loop because we have the loop through. So we're going to have some type of loop. And let's think. So for some element in the range 0 to the number of years, what do we need to do with those elements? Let's think about it. We're going to increment this by 1. Let's think about this. Let's think of the formula. I'm trying to come up with a formula here. Let's try this. Pop list some element in index I. So let's start at 0 and move way up. Trying to think back of a good formula for this. A is equal to P bracket 1 plus I to the power of N. It's really it, isn't it? Something like that. Current, I think it's current death. Let's try and have a look at this. Pop list depend. It's gonna have to be in a bracket, isn't it? There we go. So pop list, whatever is the first one minus the first one multiplied by the rate, basically. Okay, so you're taking away the dead people from it, and then you obviously have to add in I. I'm gonna have to add in the live people, or the new people, sorry, the live people. You're taking away the dead people, but you're adding in the live people. That's basically what you're doing there. And then you're obviously adding in. I'm just going to copy this again because it's the same crap again. You're adding in the migrated people. You're adding in them. Yeah, should be it. So it's going to be right. Just realizing there that that's going to be 0. So they'll all be 0. So we have to have the original. So whatever the current pop. Just realize that there. Sorry, the current pop has to be the starting point. So it'll be current pop, okay, so which is what that is, minus the dead people, plus the new people, plus the migrants. So you're losing the dead, but you're gaining 2 types of new people. Okay, so let's check, does that work? Uplift. Run that. There we go with round numbers. Put in random numbers just to see does the actual formula work. Don't care what it does, but as long as it produces something for me. Okay, let's see where that error has come up. Line 16, type 4 plus non-type and float. Okay, so it's not happy. Let's see. String, it's saying a string went in somewhere. Okay, let's check all these again. Pop underscore list dot append pop list I minus pop list I times current plus pop list I divided by plus pop list I current current pop. Okay, and 16. Okay, let's check this again. Here. Right. Pop list append. Pop list append pop list I minus pop list I. There's the bracket. There's the bracket. One, two. Must be here. Let's try that again. One. Yes, worked. Brackets, people. Brackets, brackets. At least the error was telling me. So You needed to keep them in brackets in order to generate a number, and it wasn't generating a number. Right, okay, so we know that works. So now that that works, let's just finish off the rest of this loop. So I can get rid of all that. I like this, and I didn't care what those numbers were. It's obviously not true. I know it actually this generates a number when it works, so I just need to tag the rest of it in with it now. Right, current debt equal to what I'm doing here is every time it's going to go through this, okay, I need to have the new current debt because obviously the original current debt will be just for the first year. So you need to adjust the new current debt, but what I think is the projected current debt. So every time it goes through this loop, it's going to create a new current debt based on the old one. And obviously that will start with the original one plus the projected debt rate. If that makes sense to you. I'll do the same for the birth. And obviously I'll do the same with migration. So every time this line 16 loops, it'll look for the current, the current, and the current. And of course, each new current is made up of the previous current plus the projected. So that should figure that all. That should figure out each time. Now, the year list has to be appended as well. Year list. We need to append that with the all that's going to do is take the year and the index for that year, so 0, 1, and add 1 to it. Obviously, you need to put in the first year, which is start year. So 2023, and that'll be the first one then. 2024, it'll add 1. 2025, it'll add 1 to 24. So that should build up all the years in here. So eventually what I should have here is all the years. So if I do it for 1,000 years, I'll have 2023, 2024, all the way up to, 3023. And then the current population, it'll be 5 million, 6 million, all the way up to whatever it is in 1,000 years' time. And because each one of them will marry up, it'll just be a matter of taking this is my x-axis, this is my y-axis, and plotting those two lists against each other. That's where I'm kind of going with this. And that'll give me my visual simulation of it. And obviously I want to test this. Let's do a quick tester. So in the year, and it'll take each year and it'll print that out for me. It'll be a long print, but I don't care because at the end it'll give me my simulation. But it'll give me the bit by bit. we'll do this. Obviously, I'm going to throw because these are in the thousands. So I'll just add the 0 to it. So it'll turn the thousands into millions if need be. Now, hopefully that works. Let's run this. Okay, problem. Let's see. And these things there, line 21, in the year. Again, in the year plus string plus. Have a look and see where I've gone wrong. Okay, so I've got a string plus another string plus another string plus another string. Ah, I see it here. Look, look, that one there is brackets around it, and then there's a plus. Should be a bracket around that. Okay, and it obviously just means I need to tie that off. Too many brackets, the bracket's in the wrong spot. Okay, here we go. So, in 2023, there's 1,000 people, and then there'll be 999, and in 100 years' time, there'll be 84 people left. Now, obviously, you can round that to the nearest person if you want, and make it a bit nicer. You know what I mean? And you probably need to do that. But obviously, that's doing it, and it's appending it in there. So let's do the next stage, which is to visualize this. So this isn't too hard then. Okay, so in order to visualize, let's import Plotly, which is obviously one of the Plotly, import. There's lots of different ways of doing this. You'll probably find a nicer way than me. I just Googled this to find a nice way of doing it. Lots of different ways of importing from Plotly. Just be aware of that. And most of you would have some proficiency in doing this already from your ALT2. So I'm expecting your plots to be half decent. So let's have a look. I'm going to use dictionary. We haven't really done much, but we'll see. Let's have a look. Let's get the data. Using a dictionary, everything has quotes around it, and then semis. The scatter plot, no harm there. And the Y of the scatter plot is going to be your population list. We talked about this already. And the X is going to be the year. Makes total sense. And then we'll do the layout. And again, you can do anything you want there. You can have so much fun with Plotly stuff. And like there's so many things online to help you out there. Oh god. Pop you This could be the title on the graph, basically. And we have to finish it off. We started with smooth brackets, curly brackets, so we finish with curly brackets, smooth brackets. Right. So let's see, does this work? Ooh, no module name Plotly. Well, we know what to do there. I'll do a pip install. No, pip. There we go. In she comes. Remember, if you don't want to do a pip install, just go to Tools, import manage packages, import Plotly. But I just pip install. I just enjoy it because I can physically see it going in, and I just trust it better. Pip install, but pip install won't work on your school computers because you need to have admin privileges. So if you're using your own home computers, it's probably best to do pip install. If you're using a school computer, just use Tools, manage packages, that type of thing. Let's see, has this worked? Hopefully it has. No, of course not. Why not? Why would it work? So let's go and try the other method. Manage packages, Plotly. Plotly. There we go. That's telling me it is installed. Yeah, because usually it'll come up here, please install. Well, it's telling me it is there. So let's see what the problem is. Plotly. Ah, I spelled the bloody thing wrong. Plotly. Line 2. LY. Okay. Okay, let's go with 1,000,000 people. 1, 2, 3, 4, 5, 6. What's the current year? 2023. The current birth rate is, I think it's 2.7 per thousand. The current death rate is 2.6 per thousand. And what's the current migration rate? 1.2. The future birth rate is meant to be 1.8. The future death rate, let's bring it higher, 2.9. And the migration rate, 0.8. I have no clue what this is going to do. How many years? Let's go 1,000 years into the future. Jesus, 10,000. Ooh. Okay, these are big numbers. Oh my God, we're all going to die. So, there you go. We'll start at 1,000,000, and by 2020, they're all dead. Or 20, and basically in 70, yeah, in over 100 years, everyone is dead. Okay, so that's not exactly the best. That would not be the best one to view. Right. Uh, let's change. Yeah, I'm not going to try and play around, but you can play around with those numbers if you want. But probably use real numbers from real countries. But that's basically it. That's how you do it.